No. Yeah, I'm going to. I know I did, so I've got to do it this time. Oh, I'll try to make some next week. I have to get a gallon of buttermilk, but you got to try it. Can't be like, oh, and then, you ever tried it? No, you got to try it. At least I can educate y'all on something good. All right. Did I hit record? Yeah, I'm recording. All right. So I tried to pull up the textbook, and I can't. I still can't pull up the textbook. So what I did is I pulled up the homework to see what kind of homework we're going to be doing in 8.3 and 8.4. And it's just a continuation of what we did in 8.2. 8.2, you did the basics. You did the right angle trig. There, you did that. And use the appropriate reciprocal identity to find the exact secant. You don't even have to use the reciprocal identity. What is cosine? The adjacent over the what? So now you can take the hypotenuse, which is 81, subtract 49 from 81, and then you've got your what? The opposite. And then you can do the opposite over the adjacent, or you can flip it and make it 9/7 to the 1. Depends on what they ask you for. They ask you for, they give you the cosine is equal to 7/9, and you need the sine, then plug it through the Pythagorean theorem, get that opposite, or get the opposite, and then plug it over and put it over the 9. So that's what we did in 8.2. 8.3 is a continuation. So you might have to think a little bit. You find one that's pretty decent. I'm not going to do that one because that insults your intelligence. I think you can do that and no problem. Trying to find a test question. All right, there's one. What is the exact value of the cosecant of 30 degrees? Well, you got to know your 30-degree angle. If you don't know your 30-degree angle, then you're pretty much going to suck at it. So right after 30-degree angle. Thirty-degree angle. Remember asking it already. All right. Here's your 30-degree angle. And remember, the short side is right here, the long side is right here, and this is the longest side, so that's 1. And what's longer, 2 or the square root of 3? 2 is longer, so the square root of 3 is right there. The little man is standing right here, and he's got his foot on the adjacent and the hypotenuse. Now you pretty much do anything you want. Sine, cosine, tangent, secant, or cotangent, secant, cosecant. Oscar had 1 over 2, a hump, square root of 3 over 2. Of apple, 1 over 2, 2 over 1, 2 over square root of 3, and 2 over 1. And of course, it's square root of 3. Now, you may have noticed they just asked for the cosecant. Well, why did I do all 6? It's called what? That's what it's called. It's called going above and beyond, to practice a little bit. Okay? So you type in the cosecant, which is 2. That's why when I did the first section with y'all, the 8.3, 8.2, and they asked for one certain part, I went ahead and did all 6 of them, so you would be, accustomed to that. So if you keep doing that, that will help you out tremendously. Or you can just be lazy and don't do it. Excellent. I got a star, a check. I'm sorry, check. And if you go on, we'll move on and do something different. Basically, they're teaching you your what? Your special angles. Because there's 45. Another 45, I saw it somewhere. There's the 60. And I thought I saw the 60. I thought I saw the 45. Oh well. There it is. There's that. So let's go back to this one. Try that one. Well, what is it? Well, the first thing you need to do is change it into what? Change it into degrees so you know what the heck it's talking about. So 6 will go into 180 how many times? 30 times. And 30 times 11 is going to be some BA angle. So you're going to have to figure out how many times it goes around revolutions. And then once you find out what degree it is, then you can associate it with your special angles and find the sine. So 11 pi over 6 times 180 over pi. Pi's canceled, 6 will cancel 30 times. So 30 times 11. Well, 30 times 10 is 300. So 330. So that's 330. We know from our unit triangle that 330 is 30 minus what? 360, or 30 from 360, which means this is a -1. This is a square root of 3, and this is 2. The theta is right here, so your little man is right here. So that means this is the adjacent, and this is the what? So this is the... Now what do you need? Sine, opposite half, Oscar half. So -1 over 2. And then you do all the other ones. You'd be surprised on how many people think finding the sine of 11 pi over 6 is difficult. It's not difficult if you learn the things I've told you to learn. 1, you need to learn how to change something into degrees, because 11 pi over 6, that's academic. 2, you need to know the special angles. Yes?
Is the measure of the angle 30 degrees or is it 60?
What?
The measure of 30.
I thought 360 minus 30 would be.
Oh, okay. That's the.
What did I thought it was 330.
No, you did it right. It was
Yeah, I was just wondering. What is the question?
No, if it was 60 degrees, then it would be another, I don't know what it would be.
320.
Well, we're not, okay. When we get to those angles, we'll discuss those. We're not doing those. Right now, this section is teaching you the special angles.
Okay.
So don't complicate things, okay? Next one. All right, try that one. And the reason you need to be able to do these is you need to be able to go through and do it without having to say, okay, what do I do now? 120 is what? 60 degrees, because it's one right there. So 60 from 180 is what? 120. So this is your man. So these are always on the opposite. Oops. 1, -1, square root 3. Sine, cosine, tangent, cotangent, secant, cosecant. Sine, opposite, square root of 3 over 2. 1, -1 over 2. And square root of 3 over -1. Is that right?
Yes.
And then flip everything, -1 over square root of 3. -2. And square root of 2 over square root of 3. Only two that you need to fix really is this one, which would be square root of 6. No, that one's okay. I'm sorry. Here. This one and this one. So that'd be negative square root of 3 over 3. And 2 square root of 3 over 3. All students take calculus. What's positive? The sine and the what? Cosecant. Sine is positive and cosecant is positive. Capiche? Now you understand why the 8.2 is so important. If you can do 8.2, then you can do these. You just have to apply the special angles. Negative square root of 3. Did we get it right? Yeah. Negative square root of 3. Next one. All right, write that one down. Now we're talking about the cofunction. I can't show you the book because it's not there. So, see what I can do though. Probably have it right here. I wonder if we'll go through this. Yeah, no, that's not. Not what we were doing. I don't know what happened, sorry. There we go. There. And I was going to try to pull the book up, see if it comes through here, because I can't get the book to come up. Nope, still not coming up. There we go. That's what they're doing. Writing it as a cofunction. Write that down as a cofunction because I don't have the book. I can't pull it up for you. Each trigonometric function has a cofunction. Sine's cofunction is cosine. The tangent's cofunction is cotangent. And the secant's cofunction is the cosecant. Everybody got that? All right. Thus, the abbreviation for the confunction, whatever, of cotangent is tangent. Okay? The trig function of any angle is equal to the cofunction of the angle's what? Complement. What's the complement? Whatever makes up the whole. In this case, it'd be 90 degrees. So the cofunction of 47 degrees would be what? Be 43 degrees, yes. Be cotangent of 43 degrees. Is that a test question? No. But you need to know if you ever come up on it. Cotangent of 43 degrees. I'm sorry, what? Oh, yeah. It's the complement. What's the complement of, well, let me explain. I have to show it to you through this. There it is. It's a complement is a term that's used in math. A lot of times it's used in probability and statistics. Let's say I have $1 and I use 35 cents of that dollar. What's the complement of 35 cents? 65 cents. What's the complement of yes? No. What's the complement of true? False. It's whatever makes up the whole. So you're talking about cofunction, you're talking about 90 degrees. So you're talking about the difference between that function, the 81, what's the complement of 81? 9 degrees. So then you can do the cotangent of 90 degrees, or 9 degrees. Sorry. In this case, you got the tangent of 47. And the tangent of 47, the complement would be 43. So you take the cotangent of 43. That's what the cotangent is. Yes, sir. Then you'd be down to 180. Okay? Depends on what the angle is. If it's an acute angle, it's going to be below 90. If it's an obtuse angle, it would be above 90. And then, of course, you would change it in relation to 270 and 180. Depends on where you at, or what quadrant you in.
So the complement of cotangent 90 would be tangent 90?
Yes. Okay. How important is that? I've been in engineering all my life, and I've been in surveying all my life, and I've never seen a use for the cofunction. Just letting you know. Now, the other stuff that we're doing, yes, I've seen it over and over and over. The stuff that I hammer is the stuff that you're going to see. This, you're not going to see. Just know how to do it in case it's on a standardized test, because that's the only place you're going to see it. This won't be on my test, no. But see, I don't have a test. I don't have a book to pull up, so I have to go by your homework. So, now, what if it's in pi? What's the first thing you do if something's in pi? Convert it to angle so you know what the heck you're doing. Okay? Reference angle is the back angle to 120 degrees. 120 degrees would be 60 because that's 180. The reference angles are 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Everything relates to those reference angles. All right, so if you turn 120 degrees, the complement would be, it's greater than 90, so that would be what? 60 degrees because it goes to the next one. And I think that answers your question. If it was 78 degrees, then you would say 12 degrees. Because 12 degrees is complement 78 to 90. Okay? Pretty much no. If it's a negative angle, that means you're turning counterclockwise. Which, in fact, in the real world, when you turn a transit, you turn it this way. You turn it, I guess, the opposite of what they say. They say that this is the way you turn an angle. Well, you never turn a left-handed angle in the real world. You always turn right. Because all theodolites or transits are set up to turn right angles. So you turn it this way. In academia, you turn it this way. Anyway, thought you'd find that interesting. Okay, I'm waiting for some more test questions. There's a test question. Find the exact values of the 6 trigonometric functions for the following angle. 210 degrees. Go ahead. If you can't do it, just chalk it up as being a failure. What's the first thing you do? Find out where what? Where you are. First rule of survival. Find out where you are. So, and again, I showed you this in 8.2. What do? You draw your line, and you know that this is 180, but where is this guy? What's 180 plus what? 30. It's easier when I show you all this stuff at the beginning, that way you get it. That's -1, this is 2, and this is negative square root 3. Sine, cosine, tangent, cotangent, secant, cosecant. -1/2. Square root of 3, negative square root of 3/2. -1/square root of 3. And then flip everything. I like to keep that negative down here with this, so and the secant is the 2/-1. So -1/2 is your answer there. -3/2 is your answer there. This one is the square root of 3/3, right? All students take calculus. What's positive down here? Tangent and what? Cotangent and positive. Yep, that's right. So this one is what? Square root of 3. This one is 2 square root of 3/3 with a negative out front. And this is negative what? 2. Sure. Oh, I just left it off. Just one of those things you do every once in a while. It's medication. There we go. So you can do these things all day long. I'm not going to answer all of them, but I'll answer the first two, or I'll show you the first two. These are test questions because you will never, as long as you are doing up to calculus work, you never will get away from these. So it's kind of like the factoring that you did in algebra, and kind of like the logarithms and the exponential rules. If you didn't learn them, then you sucked at algebra. Okay? If you don't learn those 6 trigonometric functions and how to obtain them, no matter where you are, you're going to suck in trig and calculus. Okay? So make sure you learn them. I don't care. Study them until you dream about them at night. I mean, you have to learn them. If you don't, it's not going to be good. Now pi over 4, do that one. First thing to do is find out what you are. So, pi over 4. It's 45 degrees. So that's pretty simple. 1 square root of 2. So sine is going to be 1 over what? 1 over square root of 2. 1 over square root of 2. Tangent is going to be 1 over 1. So the cotangent is going to be 1 over 1. And then these two are going to be square root of 2 over 1. And square root of 2 over 1. Which is equal to square root of 2. Drill, 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 over and over and over. Now, of course, I'm not going to sit here and tell you how to punch the tangent of 50 in your calculator. I think y'all can do that. Is that a test question? No. Can I teach a monkey how to do that? Yeah. So I'm not going to put those on the test. But you can do these problems left and right on the calculator, because some of y'all were on the calculator drill team in high school. Right? Right. So that's how you do 8.3. 8.4. Continuation, again. Well, Pythagorean theorem, you should know how to do that now. Taught you how to do that back in 8.2. But what's the difference? They don't give you everything. So how do you solve it? And then you use your trigonometric functions. So let's use your trigonometric functions. What do? Well, the first thing you need to do is find out where you're at. So put your handy dandy man right here. And his foot is on the what? Adjacent and the hypotenuse. Which one do you have? You've got the hypotenuse, so you've got to use either the sine or the what? Cosine, because that's the one that has the hypotenuse in it. So take your pick. Sine of 4319 is equal to Oscar had O over 961. And solve. The little man is right here. That means he's looking at what? The opposite, and his foot is on the what? Adjacent and the hypotenuse. So that means, since you have the hypotenuse, that means you've got to use the sine or the cosine, because the sine is equal to Oscar had, and the cosine is equal to a hump. So take your pick. It doesn't matter to me which one you do. I'll pick the cosine. I'll pick the sine. So the sine of 43 degrees, 19 minutes, is equal to Oscar had. Now how do you solve for the opposite side? Right. How do you clear any fraction? You multiply by what? Multiply by the denominator on both sides. You multiply by 961 on both sides. So I'm going to multiply by 961 here. I'm going to multiply by 961 here. And somebody crank that out in the calculator. And now you've got the opposite side. And this is the time for interaction. If you don't understand what I'm doing, you better speak up. Oops, sorry. Okay, so cosine, I'm sorry, sine, dork. Sine of 43. Now I think I hit math, don't I? Which one did I hit? Angle? Second angle? There it is. 43 degrees, 19 minutes. Close parentheses. Times 961 equals 593.47. So my opposite is equal to 593. Really? 593 point what? 0.47. Now, I must have typed something wrong with it. Unless yours is in radian mode. Well, then I'm done something wrong. I don't see why I did anything wrong. Let's check. And that's the way put it in radians. Sorry. I suck. Second. Entry. Now try it. There we go. 659.27. 659.27. $629.57. Now, huh?
It's 659.
Thank you. Yeah. 659.20 transpose the numbers. All right, now find your adjacent side. How can you do it? Well, you can do it by trig, or you can do it by what? Pythagorean theorem. 961 squared minus 659.27 squared is equal to a squared. So you can do it that way, or you can do cosine. You can do cosine is equal to a over 961 and put a cosine right here. Either way, you're going to get the same answer. So we take our handy dandy cosine, hit second function, entry, go back here, and hit cosine, and enter. 699.2. Write that down. Because now I'm going to take 961 quantity squared minus 659.2748 535 squared equals, and then raise that to the 0.5 power, 699.1978. It's a miracle. Now, why did I have to type in all those 7 digits? Because if I didn't type in the 7 digits that were up here, right here, or the next step up, then I would have got 699.1923. It wouldn't have matched right here, or wherever I had it. There it is. So I had to type in all those digits to get it to match. Now, what else can you find? What else can you find in the triangle? The third angle, which is B. How do you do that? By adding up C and A and taking it away from what? 180. What do you mean? No, that's minutes. See the minute symbol? That's minutes. That's, yeah. And then take that difference and multiply it by another 60, and that would be the seconds. But that's already in minutes. Okay? And that's in the first part of your book, 8.1. How to change degrees, minutes, and seconds into decimals. I'm sorry, what answer where? To get B? To get the angle B? Okay. Each triangle, if you add up all the angles in any triangle, what's it going to equal? 180. All angles, the summation of all the angles in a triangle, is equal to 180 degrees. So how many angles do we have? We've got 1, 2. So to find the third one, you do 180 minus 90 minus 43.19. 43 degrees, 19 minutes. And whatever that comes out to be, that's equal to angle B. Oops. Angle, just take 180 minus 90 minus 43 degrees, 19 minutes. Well, 180 minus 90 is 90, and 90 minus 43.19 is going to be 46, 51, 46 degrees, 51 minutes. You should come out at 46 degrees, 51 minutes. Somebody check me. And that's that angle up here. Y'all check me?
41.
Okay, 41. All right, let's try another one. Huh? Whatever they ask for. I've answered everything. I don't know what it's asking for though. Hold on. They want angle B, yeah. But they might ask for something else. So 46, 41 or 51? 41. Nice work. Yep, they do ask for more. So the length of side A, what do we find side A to be? 659.27. 659.27. And side B is, where is it? I don't think I wrote it down, did I? Oh yes, in the calculator. 699.2. It's rounding. I'm not worried about that. Is it rounding? Yeah, they said round to the nearest split. Okay. All right, try that one. I'm going to give you a minute or two because I want you to do everything. I want you to fill in all the gaps. It's 44.9 degrees and 126 meters. Sorry. I'm just going to take this thing over. Let's see, snip. New. That's very irritating. All right, so there's our angle, there's our triangle. And there's our man. And he has his foot on the adjacent. And the hypotenuse. Now we've got the adjacent, right? So if we have the adjacent, Oscar had, does no good, a hump, cosine of apple, tangent. So our trig functions that we can use is the cosine and the what? The tangent. Take your pick, I don't care. So cosine of 44.9 degrees is equal to, Oscar had a 126 over what? H, a hump. So I got to multiply both sides by H. And I get H cosine of 44.9 degrees is equal to 126. Now what I need to do to get H by itself? Divide by cosine of 45, whatever. Cosine 44.9 degrees. And H is equal to whatever that comes out to be. So you take your handy dandy calculator. And you say 126 divided by parentheses cosine of 44.9 degrees. Close parenthesis, and that's equal to 177.88. I was making sure it was the longest side. So H is equal to 177.88. Now, you can use the tangent to find n, or the opposite side, or you can use the Pythagorean theorem. I'm going to use the Pythagorean theorem. 177.88 squared minus 126 squared, and take the square root of that. So you take your handy dandy calculator. And you say 177, actually you could do parenthesis, 177.88 squared minus 126. I'm thinking 2 or 3 steps down the road. Raised to the 0.5 power. See if I get it right. Nope, I did not. Oh, I didn't raise it. Thank you. Second entry. And the insert. And shift. No. I need to do that. So. Bang on enter. 125.2056. 125. Whatever. 56. $125.56. And now find that angle. And that's going to be 90 minus 44.9, which will be 45.1. 45.1. Now, if you can do these problems you can pretty much do the preceding sections. You see what I'm saying? The preceding sections 8.2, well, 8.1, 8.2, and 8.3. I don't know what section this is. Okay, leads up to 8.4. So if you can do 8.4, then you can do the others. So let's do nerd, because these are your test questions. The ones I'm doing right now, they're pretty much your test questions. So let's see what else we got. Is that all that's left? Huh? Well, it covers the review, the algebra review, and 8.1 through 8. I gotta look. Let's see. All of this. Okay, we just did, I don't know, 8.3, we just did this one. So let's look at 8.431. A security camera is to be mounted on a bank wall as to have a good view of the head teller. Find the angle of depression of the lens. Just find the angle. The angle of depression would be this one right here, probably. So that means you got to find this angle. And you might have to find this angle too. Okay? But they give you two distances. So you can find this, and then you can find all kinds of stuff. So go ahead and work it out. It's like a puzzle. You sit there and stare at it and tell yourself you can't do it. And after a while, what do? Huh? Quit. Oh, did she leave? Is she disgusted or mad or both? She both, huh? What? Yeah, she probably mad at me. Are you serious? Was she mad? I didn't say anything, did I? I think I said anything. Now I'm gonna worry about that. Maybe she got a text or something like that. Oh, it was Mr. Smith. Did Mr. Smith say something? What? I'll give you a hint. First thing we're going to do is Pythagorean theorem. How does this compare with the first couple of weeks? A lot better. Did you have to
Well, we didn't
Yeah, he's not here today. He comes in there. He's coming from Lavon. He manages the youth at the end down there. It's not far. It's a great drive, and you go down there. You have everything you need. And it's one of my little places I go when I want to get the hell out of town. Lavon. It's nice. And I go to stay at his hotel. Surgery he manages that. Right beside JP was down there. Last time I went down there was the Georgia Alabama game. I sat in that bar and I sat in this one. And watched that Georgia game, and I was like, no, Georgia may have the team this year. Good God Almighty. The wrecking crew from Alabama just obliterated Georgia. That Alabama is a wrecking crew. Huh? Yeah, they're in the SEC. That usually happens a good bit in the SEC. All children's conference, they play in the
It's
sandbox.
not as good, not as good.
Huh?
Not as good as SEC. Is the England confession 64%?
Interesting.
No.
Excuse me, I'm not finished talking, okay?
We're talking about football.
Yes. Alright. So, thanks to Mr. Smith, we have to get started on this problem.
I'm just saying, we're just saying.
No, it doesn't.
Well, let's look at how we
Oh, if you wanted to go with that, we could pull up any team in any conference and they suck at least 1 year. Oh, that's right. Clemson doesn't suck at all. Clemson is just perfect all the time.
They have a complete study.
Well, you said that I didn't. I'm going here and I'm going here. There we go.
See, ooh, you are one more Hawks. What?
What are you talking about?
I don't know. I think he's on drugs.
They lost to Tennessee.
All right, 5.91. I thought you were doing math.
Okay, so they didn't do all that bad. They went 10-3.
Food.
Georgia.
Yeah, they didn't do that bad. They just screwed Mark Rich, that's all. So, that's the square root there. I don't know what you're talking about right now, so I can't. I bet you $1 they'll have to play Alabama before it's over with. If any team, anybody's gonna have to play, they're gonna have to play Alabama. I don't care what conference they're in. Yeah. 5.91. Oops. 5.91 squared plus 12.51 squared is equal to, raise that. Sorry. Equals. And then raise that second answer to the 0.5 power. I got 13.84. What'd y'all get? 13.84. I'll make sure that's along the side. It is 13.84. At least they aren't North Dallas Community College, which a lot of teams play their first game. That's not a real school. I just made that up. Huh? Yeah, who plays? So who does Clemson play and who does South Carolina play?
South Carolina plays Vanderbilt. Clemson plays Auburn.
Yeah.
Who does Georgia play?
Georgia plays North Carolina.
Well, at least they're not like North Dallas Community College. Well, the last three seasons, all of them have. It's like high school, junior college tryouts or something. Everybody plays a cupcake team their first game. I mean, Clemson somebody played Central Florida their first game. Who was that? And then Citadel. Somebody played Citadel. Michigan found out when they played Appalachian State not to do that anymore. And Appalachian State beat them.
Yeah, one of the companies go there.
Couple of years ago. All right. So now we can do anything we want. So how about sine? Sine is equal to Oscar had, so that's going to be 591 over 13.84. And now we want to find theta. Theta is equal to the inverse sine of 591 over 13.84. Somebody give me that.
25 to 13.
25.3 is good. 25.3 degrees. And now that we know that angle, you can find this angle. So if somebody take, that's gonna be 25, that's gonna be what? 64.7. So if this is 64.7 degrees,
Yeah.
what is this?
25.3.
And that is it.
That's in the
25.3. Well, let's look at this a minute. Let's answer our own question, Mr. Smith. Here's our drawing. I'm gonna draw it a little bit because I already got this. We got this horizon right here,
Yeah.
and the camera is mounted right here, and it's looking this way.
Yeah.
And then if they wanted to, if they want to see the head tiller over here, it's got the what? And down, what's another word for down? Depression. I'm gonna tell you, like I tell my 9-year-old, sometimes all you have to do is what? Think. All right, I heard somebody zipping up, so that means it's time to go, right? All right, so what section is this? So what should everybody be working on for homework? 8.1 through 8.4.